Hi, I'm Ron Grunsby with Photonics Online. I'm here at SPIE Photonics West 2013 in San Francisco with Steve Eglash. He's from Stanford University and is the chair of the Green Photonics Symposium. Steve, thanks for being with us.
Ron, it's a pleasure.
Tell us a little bit about your background and what you're doing at Stanford.
The Energy and Environment Industrial Affiliates program at Stanford helps to connect people from industry with the professors and grad students at Stanford. You know, Stanford's a real entrepreneurial and pragmatic place, and so the students and professors really appreciate the opportunity to connect with people from industry and understand real-world problems and opportunities.
Okay. And then moving to the Green Photonics Symposium, for people who are new to Photonics West or haven't had a chance to really look into it, tell us a little bit about it.
We created the Green Photonics Symposium a few years ago to recognize the increasing importance of photonics technologies for sustainability. We created it as a virtual symposium, recognizing that papers in green photonics are also going to relate to one of the traditional symposia in Photonics West: solid-state lighting and displays, communications, energy, and so forth.
And what are some of the most exciting presentations and technologies you're seeing this year?
You know, there's a lot going on. It's great. People are using lasers and other optical technologies for manufacturing, both to etch and remove material, as well as adding material in what a lot of people call 3D printing. Of course, photonics is an integral part of solar photovoltaic energy and solid-state lighting, and so there are a lot of papers there. Also, optical communications.
Steve, what have you seen as far as the evolving of green photonics, and what do you see in the future?
Some of these technologies were experimental and very science-oriented a few years ago, and now as the technologies and the applications have matured, we're seeing them make a much bigger commercial impact. The place where this is perhaps most dramatic is in solid-state lighting. The papers of a few years ago were about trying to develop better LED technologies. Some of the papers this year are about the commercialization of those technologies and building LED lamps that meet the requirements for people like you and me to actually put them in our homes, offices, and factories.
What are some of the biggest challenges in that field?
In the case of solid-state lighting, the field's really maturing. The cost and performance of LEDs is now getting very close to where people are going to want to install them and put them in their homes, offices, stores, and so on. So there we're seeing the development of a major commercial industry. In the case of photovoltaics, the situation's a bit different. The Chinese manufacturers of solar panels are producing high-quality panels at low cost, and so the people developing photonics technologies for solar energy are having to figure out how to fit in to a very competitive marketplace.
Okay. Well, Steve, I appreciate the time that you spent with us. Enjoy the rest of the show.
Thank you. My pleasure.